We are going to be rotating today. In the red area, we're going to work on getting your pre-lab okayed and working on Learn Smarts and homeworks if you haven't got those done. This will be the last day in class that you'll have any time to do that. So if you haven't got your homeworks or your Learn Smarts done, they need to be done outside of class. Pre-lab needs to be done and stamped before Friday when you come to this class. So if you don't get it done today in class, you have tomorrow before and after school, you have Friday during tutorial to get it done. In the green area, you're going to be doing two little mini labs. You're going to be doing a Le Chatelier experiment, and you're going to do an we're not doing an endo-exo, that one we did last time. We're going to do a burn calories lab. So we're going to be getting about 30 minutes in each of those rotations. Okay. Before we do that, I want to really quickly go over Le Chatelier and see how much you remember over the break. Okay. First of all, here we have a reaction that is at equilibrium. You'll notice the double-sided arrow right here. Okay. On one side it's pink, on the other side it's blue. We're going to now put a stress on that equilibrium. So it has to be at equilibrium to start with. If it's not at equilibrium to start with, Le Chatelier does not work. Okay? So it has to be at equilibrium to start with. Le Chatelier says basically, if I put a stress on the system, for instance, here I am cooling down the liquid. So remember that I told you you're always going to put arrows, and the arrows are always going to point down, depending on what you're doing. If you're putting it in, you're going to put it above the reaction. If you're taking it out, it goes below the reaction. Since we are cooling it, we're taking heat out of the reaction. The arrow has to cross the double-sided arrow. And since it's pointing away, it has to come this way. So the reaction is going towards the reactants, and so we should see a pink color. Okay? So they can ask us two things. What color is it, and what direction is the reaction shifting? So if we add chlorine, if chlorine is added, again, we're going to put the arrow up here this time because we're adding chlorine. The arrow's got to pass over the double-sided arrow, so it's got to go like this. So it's going to become more blue, and the reaction is shifting towards the products. Then if we go to the last one here, CO is removed. If we remove this, again, the same shift is going to happen that we had at the beginning. It's going to shift this way. It'll become more pink, and then we get more reactants. Okay? So on this next slide I'm going to show you, I'm going to have you participate. So if you show me your finger, we're going to the products. If you show me your thumb, we're going back to the reactants. Okay? If we're staying where we're at, I'm going to have you give me a hand up like this, like stop. Okay? So here we go. Look real quickly because you're going to have to do this on the test. You won't be able to put the arrows on it. You're going to have to look at it and say, okay, what's happening? Where would I put the arrow? Which way is it going? Okay? On a count of 3, tell me which way I is going with your fingers. Remember, finger to the products, thumb to the reactants. Stop, it's not moving. Okay, 1, 2, 3.
I didn't hear what you just said, so I'm just pointing out.
Okay, it should be finger towards the products because I'm putting it in here. It's shifting this way, so we're going that way. So it is our finger. Okay, on count of 3, number 2, or II. Decide which way it's going. Remember, finger towards the reactant, thumb towards the product, or stop, meaning it's not doing either. 1, 2, 3. Ooh, I've got some of each. Okay, so if I'm removing, I'm taking this out. Let's change colors. Taking this out, right? So it's got to shift towards where I'm making the hole. So it should have been a finger.
I read it wrong.
That's what you got to be really careful of when you get the test. Okay? So if you have to write down the equation on your scratch piece of paper, is it a bad thing? No, it's not a bad thing. Go ahead and write it down, and then you can use the arrows and you can see what's going on. Then look at the choices. Okay, last one. Again, on the count of 3. Here we go. 1, 2, 3. Okay, should have been a thumb. Thumb is heading back towards the products because we're putting stuff in, reactants. Putting stuff in here, and we're heading backwards. So we're heading back towards the reactants. All right, we're going to do one more. Before we go to the next slide, though, there's one that the arrows doesn't work on. That's the Le Chatelier. Does anybody remember what one it was? Well, we did Le Chatelier, but we didn't do the arrows to figure it out. There's one phase that we had to look for. Gases. So on gases, they could talk about decreasing the volume, or increasing the volume, or increasing the pressure, or decreasing the pressure. Okay, what did I look for? He said gases. What am I looking for on the gases?
For what?
Okay, those things will affect gases, but what am I looking for in the equation with the gases? You're looking for how many moles of each. So you're looking at the coefficients of each and which ones were gases. So you can figure out how many gases are on the reactant side, how many gases are on the product side. So if I had 3 gases on the reactant side and 4 gases on the product side, and I decrease the volume, which way would it go? Decrease the pressure, right? It would go towards the product. If I increase the volume, which way will it go? It's the same way, towards the product. What if I increase the volume? Decrease the volume, towards the reactants. If I increase the pressure, towards the reactant. So a side that has the least amount of gas is where it's going to go if I increase the pressure or I decrease the volume. And you think about it, if I'm decreasing the volume, I'm actually increasing the pressure. If I'm increasing the volume, I'm decreasing the pressure. Okay? All right, so let's go on to this next one. Let's see how well you do on this one. This one has a trick in it. Okay, so look at number 1. Decide in your mind, are you going to point towards the products with your finger, or are you going to thumb at the reactants with your thumb, or are you going to tell me, stop, it's not doing anything? Ready? In 3.
That's the first one, right?
First one. 2, everyone participating, and 1. Okay, this one you can do here, right? You're removing this, so you've got a cross coming this way, so it is moving that way. Okay, second one. You're at equilibrium, so you have to have some of it. Of either one. Okay, so next one. Heat is added. Ready? In 3, 2, and 1. Ooh, this one should have been a thumb where we head back, because if I'm adding heat, I'm putting heat here, so it's got to come across here, so it's going backwards towards the... So thumb towards the reactants, pointer towards the product, stop, it didn't do anything. Okay? All right. The last one. This. Okay, make a decision in 3, 2, and 1. Those of you that did a stop sign, that is correct. Why? It's a solid. Remember in the KEQ, solids and liquids were not in the KEQ. We're not in the K equilibrium. They do not affect the equilibrium. Solids and liquids. So if I have a solid or a liquid, it doesn't do anything. Okay? So we're just working with aqueous and gases. That's the only thing that can really affect equilibrium. All right? So that's just a quick review of Le Chatelier, so that hopefully it'll get in your head again and you'll be able to do it. So we're going to do, in the green area, you're going to do a quick Le Chatelier. Now I'm going to push you to make sure you get through these two little mini laps. Good luck. Everybody look at your second page, because I want to explain it all to everybody, and then we'll go from there.
Which one is the second?
So Le Chatelier's, equilibrium and Le Chatelier's principle. Look at the second page, or the back of the first page.
Who is Le Chatelier?
Le Chatelier is the one that did a whole bunch of experiments with getting an equation at equilibrium and what happened when he changed things. Would it go back to an equilibrium? So this is your hands-on equilibrium lab. So what you're going to do is you're going to go grab 2 cans over here, and you're going to grab a small beaker and a large beaker. You're going to grab 2 rulers. You're going to fill the cans with water, no more than 1/3 full, but they're going to be at different heights. Okay, you're going to put a ruler in each of the cans. Number 1 on here is the reading that you have initially in each can. One of you, so you got to do this in partners, one of you is going to be the reactant. The other person is going to be the product. Okay? So, you're going to take, and one of you will have the large beaker, one of you will have the small beaker. You dip into the cans, and at the same time you trade the water. Then you put it down and you read it, and you put it as trial 2. Then both of you dip, both of you pour. Set it down, read it again. Once you get a reading for each of you, 3 readings in a row that is exactly the same. That doesn't mean each of us have 5. That means I get 3, 3, 3, and he gets 11, 11, 11. Okay, we've got 3 readings in our can that are the same. And his can, 3 readings that are the same. If you did read general chem, you did. So we're going to do that really fast. Once you get there, you're going to put a line down or an X in the next trial. Then, I want you to stress the system. I want you to take a big beaker full of water out of the one that has the most water and dump it down the sink. Take the next reading and do it again until you get to equilibrium. Yes?
This is just practice for
Le Chatelier. Mm-hmm. And to be able to see what the graph looks like. So I want you to do that. Then you're going to write the graph. Now down there at the bottom it says original volume of the beaker, large beaker, small beaker. Don't really care about that, but the end beakers, that would be nice to know. Okay? You don't have to write all this up. I'm just giving you this to do. I'm borrowing his. I would like you to have done this part though and get those last 2 and then graph it so you graphically see what's going on. Pick a color for the product, pick a color for the reactant. Do a line graph. Don't worry about bar, just do a line graph to see what's happening and what happens when you apply a stress. Okay? That's really fast. I'm not going to give you much time to do that in here. Yes?
So for this one, we're just doing this, not like the pre-lab with the analysis?
Nope. This is not a lab that's not going to be handed in. It's just because I know that once you've experienced it, it sticks in here better for the test. Okay? In the back, grab the other lab. So in the other lab, we're going to set it up a little bit different than what's here. So as I push this group in, I'll come back, I'll show you the setup, and then I'll have you do whatever you need to do. Up here, there are almonds or graham crackers. You can choose which one you're going to burn to find out how many calories that it will give off. Okay, the big thing here on this lab, you need to make sure you weigh your food in the apparatus below to start with and to end with. You need the beginning temperature of the water and the end temperature of water. And then you can do all the calculations you need to be able to do. Okay, and I would like you to do the calculations on this lab. This is what you need practice with for the test. Okay? Questions? Okay, so what I'm going to do is I'm going to get these guys started. Then we'll rotate in and you guys will come into this group and I'll check your labs. Okay? All right, so as fast as you can. There's cans on the bottom. There's that. You have 3 minutes. 3 minutes. I want you to have all the stuff ready and working on that. You are passing off your lab that we're doing next time. That is a lab that you have to turn in, yes. And then you're working on any Learn Smarts and or homeworks.
How long are we going to be?
30 minutes, but when they're done, you can move to that part if you'd like to.
Can we fill the cans up?
Yes, you can fill the cans up. Please do.